Welcome to clickmyproject.com.
Our product title is Built-in Self-Test Methodology with a Statistical Analysis for Electrical Diagnosis for Wear-out in a Static Random Access Memory Array. Let's we see our process abstract. In our process, we propose to match the failure rate from BIST using the volume data and failure distribution from the reliability simulators. We conduct statically analyze to difference between GTDB versus PTDB failures and EM versus SIV failures, and then to determine the separate wear out distribution in our process to verify the logic design implementations. There are many SRAM layout which are designed to be the approximate the differential applications. Among the SRAM layout methodology, we have implementation of physical layout which has many possible wear out sites. When the layout changes the site of front end mechanism which are the GTDDP and the BIST, and we go into the backend mechanisms can be different. In this case, pattern can be slightly revised the process SRAMs, and then first we build the BIST concepts to detect the wear out, the identify the locations of faculty cells. Next, the physical location of failure sites within the SRAM. The so many faults in the site from the different mechanisms which result exactly same electrical fail signatures of the site of the process, and the probability for each wear out mechanism is estimated by the matching algorithms for following the BIST and the failure rate distributions. The compute the simulation and the function of the circle use scenarios. The estimation of wear out distribution is helpful determinations wear out limiting mechanism is failed. And the SRAM system incorporates 8 banks of the RAM cells, 128 KB memory capacity. Each bank have 16 KB SRAM cells with 120 lines of the 120 bit lines pass in the process. In our process, we have the implementation of the 128 bit lines, the compatibility of bit line was. We implement the BIST algorithm. We activate the select individual cells for each test step, and then we have extend the test column address from the 4 bit in the 7 bits process. Let me see our process flow diagram. In our process, we have give the input for the test parameters generation. In the test parameters generations, give the built-in self-test schemes or the solution of testing VLSI process. BIST is used to make faster, less expensive integrated circuits manufacturing test. After we use in the CUT with DFT section. In these sections, we mainly purpose of the BIST to reduce the complexity and thereby reduce the reliable upon external process pattern programmer process. The out of the result of the function in the test, we are using the NFED PRPG generations. In the pseudo random pattern generation process, it's mainly used to generate the pattern result based on normalized distance. This technique is to obtain the pattern generation based on the test circuits process functions. The LFSR consists of DFF connector is cascade with the same clock applied the entire FF to make them act live shift resistor. This extra operations introduce a new bit introduce the shift resistors. After we go into the CFT with the DFT sections means our circuits and the test functions is consider the process of architecture. They have using the multi level of 8-bit SRAM process of the CMOS technology. We go into that perform the process device assemblies, the preventions of the circuits and device, and also the fault detectors. This stage result list of the fault identified at the device level. After we go into the output response comparator in the level, we get the result from the test controller functions. The final output is identify the fault effective and reduce the test process time output process. Responsible comparator process is comparing the data between golden signature from row process and row memory and MISF present signature level. This proposed business case is to identify the fault effect and to reduce the power consumption level due to the testing time. Let's we see our process running procedure. We have designed in our process best concept in standard tool. The designing concept we have using the CMOS level, PMOS and NMOS number of counting for 8. We have designed 8 SRAM cells. We have how we do the input read and write functions with using the fault detections using the BIST concept. After designing this process tool, we are going to the running the process. First of all, we should give the signature setup. After process completed, we are going to the give the result only. So generally the setup the spice simulation cells we create for select the transient Fourier analysis. After we go into library files is mandatory for very important for the library model generations. Just we go into the click that wherever we have the library files function generics process completed. After we go into the setup for the transient Fourier analysis time setup. What are the given input for the fall and rising the time for the clock pulse and reset, whatever maybe we give the pulse, give the input functions, we give the process completely. After we go into the running the process. So this process already we have set up, the same setup is completed. After we go into the running the start the simulation process, just we run the process, we get open the t-space and w-edit waveform process. So the w-edit waveform process we get the waveform generation of the input output process and the t-space using for the power calculation process. So we got the output from the w-edit waveform viewer. We split the each and every how the read and write pulse for write functions, read functions. So what are the give the clocks for see that split the process. So the process we give the input for the 5 voltage process. This is the voltage process. So this is main output for here we give the input functions the WWL for the after 0 to 100 is the enable functions. The same time for output for the RBL is what other time enabled for the same time bit is write read. After we give the input for the writing the full of zeros or ones after 0 to 200 pulse, but with the enable functions the feedback clock is 0 to 100 only is enable function. After we go into the zeros, so we got the output. This time limited we get the output for the bits reading the pulse. So this is the control panels for the functions. So this is our process, the testing purpose of using the BIST concept. Thank you watching our video.